Sounds good. All right, so I'm going to talk to you guys today about Terraform in Azure, and I'll start by introducing myself. My name is Mark Gray. I'm a program manager at Microsoft. Been here for quite a while and been working in the management space the whole time I've been at Microsoft. I've been in group policy, don't blame me for that. But I worked in group policy when I first started at Microsoft and then moved into PowerShell. And now I'm on a team that focuses on command line experiences for Azure. And I personally own the Terraform interface, or the Terraform interaction with Azure. So what we will talk about today, so I'll talk about some trends and things like that. First, from the IaaS perspective, or the infrastructure as code perspective, and talk about our commitment from the Microsoft perspective, as well as from my team's perspective, and then dive into Terraform on Azure, and then touch a little bit on kind of what the future looks like for Terraform in Azure. Let me see. I don't know how many people are here, or if anyone has questions, feel free to yell. But if there are no questions, I will just cruise along. All right, so let's start. Thank you, everyone, for joining me today. I really appreciate it. This is some strange times that we're in now, and I just want to hope that everybody is being safe and staying sane. If you're anything like we are here in Seattle, you've been stuck in your house for a long period of time, and it's not exactly easy for sanity. But hopefully, everyone's staying sane. So, all right. So from infrastructure trends perspective, there are a bunch of goals that companies have around infrastructure. The first and foremost is usually security that the teams dealing with infrastructure need to think about. So they need to think about the tools and services that they are providing and make sure that they are secure. Some need to be more secure than others. If the things that are the applications or whatnot have user PII and things like that, they're going to need to be more secure, or that's going to be a higher priority for the teams. Whereas if it's just a tool that an internal org is using, that is going to have a different measure from a security, but it is definitely something that the infrastructure team has to think about. There's also scale. So scale in that, is this a small app that's going to grow over time? Is it something that is an app that has to deal with spikes? So you want to be able to scale up and scale down dynamically. It's another thing that teams from an infrastructure perspective need to think about. The next thing is saving money. So infrastructure is not usually thought of as a revenue generating team. So saving money is typically top of mind for infrastructure, so that they can help the business make more money or net more money. Flexibility is another thing that is extremely important to infrastructure. Teams need to be able to choose the tool or service or whatnot that is best for the target customer or the application or whatnot. So they don't need to, or they ideally they don't want to choose a solution just because they're already using their on-prem environment or what have you. They want to be able to choose a SaaS service if that's most beneficial. And lastly, they need to be able to deliver value. Again, because it's not a revenue generating source typically, they need to be able to deliver value not only to the external customers, so the end users, but also to the people that are using the infrastructure, so the developers and those types of folks. So what this typically means is you end up with a very diverse infrastructure. So you end up with a lot of things on-prem as well as in the cloud. So you have, like I mentioned before, you can have applications and services and things like that that are being used by your internal teams. Those might sit on-prem wherever you have customer-facing things or out in the cloud. You have private clouds, you have public clouds. You'll end up with legacy applications. So there's been a lot of investment in applications that can't quite be moved to the cloud or to new infrastructure. So they're there. They still need to be managed. And then you have IaaS in the cloud where you have the VMs and the data stores and all of that kind of stuff that need to be managed. And then you can have PaaS and SaaS where you have services that are, some of the infrastructure is abstracted from you by the cloud services themselves, and you still need to manage those. And then you have the last, well, not the last, but the highest level of a SaaS service, like with Outlook 365 or something like that. But there is still some management that needs to happen there. You get away from dealing with the VMs and all of that kind of stuff, but there is still some configuration and things like that that need to be done there. And lastly, you end up with first party and open source. So a lot of times you want to have, so the best tool for the job can be a first party solution. So as an example, Azure DevOps might be a solution that a customer chooses because it serves their purposes best, where in addition to that, they want to use some open source GitHub or something like that that they want to use along with that. So you end up with this environment where you have a bunch of different infrastructure and types of infrastructure that you need to manage, and having a common way of managing those things is extremely important. And we get this information in talking to our customers, but it's also out there from broader studies, like the studies from RightScale, that is very eye-opening in that the vast majority of customers out there are using multi-cloud strategies. So they're using public, private, hybrid. So they're on-prem and in the cloud. The very small portion of them are actually not multi-cloud. So it is something that is, it's widespread, and it's not something that is coming. It's something that's here now and needs to be easily managed. And the other interesting piece that comes from the RightScale study is the number of clouds that customers are using now. It's not one or two clouds. So they have kind of an on-prem cloud and a public cloud that they're using. In many cases, they have up to 5 clouds that they're working with. So they may be working with all of the major clouds as well as on-prem and things like that. And the reason for that is that flexibility piece a lot of times where you have best of breed products out there. So their customers using ML, machine learning in a lot of their products. They will want to choose the cloud that provides the best machine learning services. So they'll look across them and want to be able to choose that. But they're also using big data, so they might want to choose a different cloud because they have best of breed big data in there. So they end up using, or you end up using multiple clouds. And this becomes, when you're using that many different clouds in different environments, being able to manage those infrastructures in a common way becomes critical. And from an open source perspective, there is a mix. In this study, there's a mix of open source. So that mix is going to be changing over time. But first party or proprietary software and open source is something that enterprises use both of now and will continue to use over time in the future. And open source is used for a whole slew of different reasons between security. So you have way more eyes on open source and way more people contributing to open source. So you can tend to get a more secure product, or at least perceived as a more secure product. You can have a lower cost of ownership, like going back to the cost of infrastructure. Infrastructure is not going to make you money directly, so the more money you can save, the better you will be doing from that perspective. So how does this all fit from a Microsoft perspective? Where does Microsoft fit in here, and why does Microsoft care? So Microsoft has, from the very top, has recognized these patterns and accepts these patterns. And our leadership across the board, all the way from Satya down, really recognize these patterns and want to make sure that we embrace open source and multi-cloud and all of that kind of stuff, and make sure that Azure is in the list of clouds that customers use, and work with the tools that work across clouds and all of that kind of stuff. And Microsoft invests, not only do we recognize that it's important, but we invest in these solutions quite heavily, and it's increased over time and as will continue to increase. We contribute to projects and things like that we start, and we also contribute to open source projects and things like that others start. So we are in that community, and we are full on in there now, and will continue to be. So one of the areas that is critical to infrastructure is how you actually interact with infrastructure. There are a couple of different ways that most customers interact with infrastructure. One of those ways is using the UI, so the control panels and things like that. When you are using 3, 4, 5 different clouds, as well as on-prem and a whole slew of different products, the UI is a good way to get up to speed, but it's not typically something that customers use long-term. And not only that, having to learn each and every one of the interfaces and UI and consoles and stuff like that can be confusing, to say the least. So from a customer's perspective, most customers use command lines, be it Bash or PowerShell or Terraform or what have you. But they typically use that for a number of different reasons. One, you can get a consistent experience. So from a PowerShell perspective, if you're managing AWS or Azure or on-prem, you have the verb noun syntax. So you can very easily manage those things and learn how to configure them and things like that, with the same kind of philosophies and all of that kind of stuff. And Terraform obviously falls into that as well. And not only that, but there's automation, and the UI can't automate, where with infrastructure, getting and working with it is one thing, but actually trying to make it more cost effective for your teams, you're going to need to automate it and provide wrappers around things and stuff like that. So the command line really allows that to happen and unlocks that potential. So what my team does is focus on those command lines for Azure. So our team is called Azure Management Experience, and we across Azure, we have a dedicated team to make sure that we have a consistent and full experience for Azure services, for the Azure CLI, PowerShell, and Terraform primarily, as well as Ansible. So we, towards the end of last year, we looked at the different tools and the services and the coverage and things like that, and discovered that are not only between tools, so between the CLI and PowerShell and Terraform, you can do different things. So some things are covered in CLI, some things are covered in PowerShell, some things are covered in Terraform. There's no consistency there, but the way that they're implemented are different. So you might have a parameter named VM in CLI, where it's named a virtual machine in PowerShell, and going between them gets confusing as well. So we presented this information to our leadership, and they essentially said, fix it. So we have built our team up so that we can have a central team to make sure that we have great coverage for all of the command lines for Azure. So we have spent this year, so we built the team up at the end of last year, and we have spent this year doing that. So that is across all of the different teams. So you'll notice that they're not only first party command lines that we're talking about here, we're talking about third party as well. So Ansible and Terraform are third party. And we, for all of the reasons that we've talked about so far, we recognize that customers are going to use the tool that works best for them. So we are going to treat the tools that our customers need as first class. So we have a team at Microsoft, my team, that focuses on this. And we work directly with the service teams to ensure that we understand not only what their service does, but we work with them on what the new features are coming and things like that, so that we can try to get ahead of supporting those things. So when they release a feature, it has support for the command lines. All right. So how are we investing in all of these tools? So when I talk about this, this is across the PowerShell, CLI, and Terraform. So right now we're working on investing in breadth. So that the study that we did, or the study that we did at the end of last year, we looked at primarily the coverage across the tools to see of all of the services in Azure, how many of them have CLI coverage for PowerShell, CLI, and Terraform. And right now we're working on building that out. So whatever services you want to configure in Azure, you will have coverage for all of the different tools. So be it managing VMs or data stores or PaaS services like AKS, or even SaaS services, you have those covered in Azure. So making sure that we get the primary scenarios essentially in all of the services and RPs out there covered. Going forward, we will kind of shift the focus to depth coverage. So what we mean by that is making sure that not only do we cover all of the services in Azure, but we cover all of the scenarios that those services need to manage. It is something that is a balancing act. We're not doing only breadth right now. We are, especially from a Terraform perspective, we have a lot of large customers that are highly dependent on Terraform. So we have a balance between kind of breadth and depth, where we're making sure that we broaden our coverage, but we are making sure that we enable the features and functionality in the existing services as well. So each of the different tools have a different mix of this balance from the breadth and depth, but kind of all up going forward, we will be shifting from breadth. We are getting to the point now that we will cover all of the services in the very near future. So after that, we'll shift like entirely the processes and things like that to depth to make sure that we get ahead of new features and all of that stuff that are coming out with these services. All right, so now we're going to focus on, now that you understand kind of the, from a Microsoft perspective as well as my team's perspective. Like I said, I own Terraform. I have a team that works on enabling Terraform, and we're going to talk about that and give some examples and all that kind of stuff. I'll start by talking about our partnership and investments in Terraform. So we work with HashiCorp. So HashiCorp is the owner of Terraform. We have a agreement with them, and we work with them to make sure that Azure is covered in Terraform. And we have like I mentioned, I have a dedicated engineering team. So I have 7 or so Microsoft engineers. HashiCorp has a similar number of engineers, and we work together as a virtual team. We have a same backlog, and we work together to enable Azure through Terraform. We have regular releases, so HashiCorp owns the release process, but we release every week at this point. It used to be about every 3 weeks. So all of the work that we're doing on the breadth coverage and the depth coverage and the issues and all of that kind of stuff gets released weekly. So as we fix these things, it's very quick to come out, and it's a quick turnaround cycle. And I should take a moment to mention that this is an open source project as well. And not only do Microsoft engineers and HashiCorp engineers work on this, but we have a vibrant community that contributes to to Terraform. And we welcome contributions, and a lot of the maintainers of the repo, a lot of their time is spent on reviewing PRs and working with the community to get that stuff in there. So like I mentioned, we have a balancing act between breadth and depth. A number of the depth contributions do come from the community because we have customers out there that are trying to work with a resource, and that resource doesn't have coverage or doesn't have a particular property or something like that, or a particular value within a property. And they can go in there and dig in and add that functionality and submit a PR, and then our maintainers will work with them to get that out there. And we have it's a significant number of community contributors at this point. Another thing that I like to point out is the Microsoft has support for Terraform. So you can call Microsoft support, and if you don't have a agreement with us already, you can pay for support, and Microsoft will help you with your Terraform issues. If we are not able to help you, or if it ends up being a core Terraform issue, we have a channel to pass you over to HashiCorp and have them help you with those issues. So the primary point here is we treat Terraform like a first-party product, and we will support you and help you be successful with Terraform. From a documents and tutorials perspective, we have both documentation in the Microsoft domain. So in docs.microsoft.com, we have a lot of Terraform documentation to guide you through some examples and things like that. But we also contribute to HashiCorp documentation. So learn.hashicorp.com has some walkthroughs, and we have a section in there for Azure that'll walk you through how to actually provision and get up to speed on Terraform in Azure. So all of that about kind of the high level Terraform, and now we'll kind of talk about what Terraform is and what it's used for, and then get into some demos and examples and all of that kind of stuff. So Terraform is used kind of HashiCorp in general. Their philosophy is to provide infrastructure tools that work no matter what your target is. So they want to make sure that their tools, and Terraform in particular, will be able to provision infrastructure, whether you're targeting on-prem or to AWS or to Azure or to whatever infrastructure target you have. And we'll talk about kind of the model and how they do that. But a common language or syntax, and then a common process for provisioning to wherever you're going to provision your infrastructure. So it's a pretty open-minded approach, and it's one that customers are choosing, and many Azure customers are using it, so we're supporting it. So one of the things that I like to, one of the myths I like to debunk when I start talking about Terraform kind of right out of the gate is a lot of customers will say, well, great, I have Terraform and I can write a configuration and I can apply that to, because it works no matter what infrastructure I want to apply it to, I can write this configuration. I can apply it to Azure, I can apply it to AWS, and I can apply it to on-prem. That is not the case at all. It gives you the same kind of tooling and processes and language, but it does not give you a common way of deploying the same configuration across all of those clouds or the infrastructure. And the reason for that is the clouds themselves, AWS and GCP and Azure, all have different underlying concepts. And if you had a single way of deploying across all of those things, you would end up with the least common denominator problem. So you would end up with a trimmed down version of a VM, because you can only deal with a VM that has common properties across all of the different clouds. So what you could technically do that using modules, but in general, you should not think of Terraform as a way to kind of have a single configuration to deploy across clouds. You can use the same language and you can use the same process, but you'll have a configuration for Azure and you'll have a configuration for AWS and whatnot. So just want to clear that up. So the next thing I want to jump into, and this is a little bit out of order from the way I typically do it, but it is a critical piece of Terraform, so I want to talk about it and then kind of show it here. And I'll talk about why. But Terraform state, one of the unique things about Terraform is that it has state and that it exposes it to the customer. And Terraform Terraform state is required, so you can't opt out of state. It is something that you have to have or have to use if you're using Terraform. And the purpose for state is it gives Terraform the ability to map your desired state, which is in the form of a configuration, to what is out there in the real world already, so that it can apply essentially a diff. So if I have 5 VMs in my configuration and 4 of them are already out there in the real world, Terraform will only create the new one or make changes to that new one. So it's going to be more efficient in its application of the configuration using that state. It also allows you to see ahead on what changes are going to happen. So Terraform has a concept of a plan. So with the state, it can say you have your configuration. And I'll use that same example that I had before. And that is if you have a configuration that previously had 4 VMs in it, now has 5 VMs, and you do a plan, Terraform will tell you I need to just create this new VM, and I will not make a change to those other VMs. So it gives you the ability to do that. The state itself contains the configuration as well as the mapping of your what's in your configuration to what's in the real world, and that includes values a lot of times. Not a lot of times, it includes the values, so that Terraform can know if something needs to be changed. So as an example, if you have a VM property that changes from 1 to 2, it needs to know that it needs to change that one value instead of deleting the VM and recreating it. So it saves those values in the state. And a lot of times those values can be secret. So it's critical to keep the state secure. And we'll talk about where it is by default. But the other thing that it does is it contains dependencies. So Terraform figures out how it's going to apply based on dependencies. So if to create a VM, you need some data disks and some NICs and stuff like that, it'll create dependencies between the VM and the NIC and data stores, so that it can most efficiently deploy that stuff. So since there's no dependency between a NIC and the data store, it'll create those in parallel, but then it'll create the VM after that. So all of that information is saved in the state as well. And there are two different types of state. There's standard state, and then there's enhanced state. Standard is just the state file itself, where it can have some locking and things like that. Enhanced, actually, that's more of a remote end, but these are the remote things there, and we'll talk a little bit more about the different types of states, the backends. So the backends themselves, the default backend where state lives. So the backend is where the state lives. The default is the local. So it's a JSON file that gets saved in the directory where the configuration is. It's a default. That is not something you will want to do outside of playing around with Terraform for the first time. Just because of the reasons that I talked about. You have secure secrets and values and stuff like that in there that you don't want just laying around on a computer. You have standard remote backends, and those are things like AzureRM, which we'll be talking about today. You have Artifactory Console and dot, 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 dot. You have a whole bunch of the other ones. And those are essentially just the state file itself in something like a blob store. Where that information is in a central place. It allows multiple people to work on it, as well as keeping it so you can better secure it in that central location. And then there are enhanced backends, and the enhanced backends are Terraform Cloud and Terraform Enterprise. In addition to the storing the state file, they allow you to do things like having remote execution and stuff like that. So instead of executing Terraform locally, it's going to do it on the central store and save logs and all of that kind of stuff out there. All right, so the way that Terraform handles or is so flexible with infrastructure and things like that is its concept of providers. So the providers allow Terraform to configure the different clouds and the different types of infrastructure and stuff like that. And one of the things that doesn't always come out when people are talking about Terraform is people think of providers as cloud specific, so Azure, AWS, Google, Cloud, all of that kind of stuff. There are also providers for things like Kubernetes and DNS and GitHub and all of those kinds of things. So you can configure those as well. And a lot of the times you can use multiple providers. So as an example, you can use the Azure Provider to stand up AKS and configure AKS. And then you can use the Kubernetes provider to actually provision stuff within AKS in Azure. So you can kind of use them together, and a lot of times in configurations you will use them together. But it really allows Terraform to work with anything that's out there. And we'll talk about the Azure Provider today for the most part. Some other things that the providers do is provide authentication. So in the Azure Provider, you have 3 types of authentication you can do. You can do the CLI authentication. You can authenticate with a service principal, and you can you can authenticate with managed identity. That's a spelling mistake there. So the way that you actually configure the provider is through the provider keyword in the HashiCorp language. And to authenticate, you need to provide some properties. And there are a few different ways that you can provide those properties for the provider. One of them is putting them into the configuration itself. So you can give it the subscription and tenant and all of that kind of stuff. You don't want to give it the client ID and secret, typically, if you're using service principal. So there are other ways of passing that in, and one of the ways of doing that is through environment variables. So you can have environment variables that actually define those things on your system. So you can actually put secrets and things like that in there. All right, so let's jump into our first demo here. And like I said before, if anyone has questions, feel free to yell at any point in time. But in this demo, we will show you state. So all I'm doing in this demo here is I'm gonna provision a resource group, and I'll talk more about what all of these different pieces and components are here. But what I have here is a Terraform configuration, and the configuration, the way that Terraform works is in a directory, it will look at all of the .tf files in that directory and pull those together and process them. And you can split up your configuration however you want, but there's some best practices on how you kind of split those things up. And typically you start with a main.tf file, and you have some of your common things in there, and then you can have other files for other components or whatever works for you. But in this particular case, I'm just going to configure a resource group, and I have the Terraform provider. I'm sorry, the AzureRM provider here with just a property that says I want to use version 2.0 of the provider or a 2.any version of the provider. And then I have the backend configured here. So the backend is to AzureRM, and it's going to store that state in a container in a storage account. And it's going to name the state file, whatever I put in the key here. So before I run this, I will show you here. I have in my portal, I have already set up a container. So Terraform's not going to create the container to store the state in. So the only thing you'll have to do to set this up is create a storage account. So I have a storage account created here. And create a container in that storage account. So in the container, I have a container named Global Siberia, and then I have no blobs in there. And this storage account can be either the version 1 or version 2 of the storage account. So it does support, this is actually a data lake storage account. So you can have, it's kind of overkill for this state, but you can use data lake, which is a massive storage service for this kind of stuff. So I have that set up. You can see that there's no file in here. There's no blob files in here. So what I'll do is come back to my Terraform console here and do so I've actually created an alias of TF just because I use Terraform a lot. And TF is way shorter than Terraform. So I'll do a Terraform init. And what that's going to do is go out and configure my backend. So it's going to set up Terraform to use that remote backend and then check my configuration for any invalid syntax and things like that. So it just does some basic stuff there. So after that, I can do a Terraform apply, and this is going to go prompt me and let me know what it's going to do. And then it's going to, when I confirm, it's going to apply that to the real world. And as part of that, it's going to actually create the state in the backend as well. All right, so yes, I do want to do that. So that will go ahead and create that resource group. So you can see here that it's going to create this resource group, and the resource group name is going to be Global AZ Siberia, and it's going to create it in the West US2 location. You can see that it created that super quickly. So if I go back to the portal here and refresh this, you'll see two things. You'll see that it created the state out there in the blob store, but you can also see that it has now, I go to my resource groups and go to my subscription here. You will see that I now have a Global AZ Siberia resource group, and it has nothing in it. So it went and created that. So the next thing I want to do to show you kind of one of the benefits of the central having a remote backend is I'm going to go to shell.azure.com. So I'm going to open the Cloud Shell and actually use that central, that same configuration and the same store there. So if I didn't have a central store and I saved the state locally, I would come into the Cloud Shell, and it would have no idea that that resource group was actually provisioned already with Terraform. So it would fail when I go to apply it, because it's going to say that resource group is already there, and I don't know how to deal with that because it's not in my state.
Mark?
Yep.
Mark, while we wait for a Cloud Shell, there is a question in the chat for you.
Okay. How do I get to that? Can you read that to me?
Yeah, sure. So the question is about a state file. Is it possible to populate it with existing infrastructure?
Yes, it is. That's a great question. The way that you do that in Terraform is to use the Terraform import command. And what that does is just what you're asking for. You basically tell it, you create a configuration that is essentially a VM. So as an example that I've used in the past, a VM. So you create a VM in your configuration that has nothing in it, and then you can do an import and point to the specific VM in the production environment, and then import that into your state file, and then you can manage that going forward from there. It is a bit of a how should I say, it's a manual process, because as it stands right now in Terraform, you have to do it one by one. So each resource that you want to import, you have to do that Terraform import for. You can't do anything like point at a resource group and say import all of these things into Terraform. That being said, there are third-party tools out there, well, open source tools like AZ2TF, that will allow you to do just that. Essentially, you can point at a resource group and say import everything, and it'll import it into state. And I think it will actually create a configuration for you as well. All right, so what I wanted to do here was I first want to do a AZ login, and I should have done this while I was talking, but I'm bad at talking and doing stuff at the same time, so. All right, so I will authenticate that. And what I'm doing here, the reason I'm doing an AZ login is by default, Cloud Shell uses a managed identity. And I don't want to use managed identity for this action. I want to authenticate. I haven't given that the Cloud Shell permission, so I'm just going to actually do the AZ login here and do a Terraform init. Oops, I'm going to actually go to the code. So if I do cd cloud, oh my goodness, /z, I think it is. So this is the same code. So if I do a list, it has the same main file and things like that. So I got the same code from over there. So if I do a Terraform init here, this will actually initialize to my backend again, and then I will do a Terraform plan, and you'll see that because it knows about it and it's using the common backend, it will say that I don't need to do anything because it's already in the state that I want it to be. And so if I do a Terraform plan there, you'll see that it actually says you need to do nothing. The other thing that this allows you to do is if I could do two things at one time, if I was in the Cloud Shell trying to do a Terraform apply at the same time I was on my desktop trying to do it, it would, whoever started first would lock the state and cause the other person to have to wait until that apply is done before that they can do an apply. So it gives you the ability to actually orchestrate changes that go out and things like that. So you can see there that no changes need to be applied to my environment. All right, so I'm going to jump back here to the slide deck and talk about kind of the flow. I've shown a little bit of this, but I'll talk about the different states of the flow from a Terraform perspective. So there's the init, like I mentioned at the beginning. The init actually initializes Terraform. So it does a number of different things, including hooking up to the state file, but it also does some syntax checking and things like that to make sure that what's in your configuration should work when you do an apply and plan. The plan, like I mentioned before, checks the current state and compares that to the state that you want or you have defined in your configuration, and tells you what needs to be changed to put it in that desired state. And the apply will apply that delta. So it doesn't apply the whole configuration every time. It's only going to apply what needs to be changed in the production environment. The last piece here in the typical workflow is, well, kind of typical, is destroy. So destroy is gonna, if you run Terraform destroy, it's gonna remove everything that is in your configuration from the production environment. So it's a good way of cleaning up. So if you have a temporary environment that you're gonna deploy, like a lab environment or something like that, you can do the full deploy, you can work with it. When you're done with it, you can do the Terraform destroy and it'll get rid of everything that's there. And both apply and destroy will do the appropriate optimization. So it knows the dependencies between different resources, and it will determine what it can create or delete before the other things or what it needs to. So resources and data sources are in providers, and they're kind of, they're the pieces that know how to configure things like VMs or AKS or what have you in the different infrastructure components or pieces. There are, in the AzureRM provider, there are resources for IaaS things like compute and networking and all of that stuff that you typically work with. But there are also support for PaaS services as well. We started out in Terraform supporting IaaS, so we have really good coverage of IaaS. And PaaS kind of came afterwards, and we have good coverage of it at this point. But that is definitely something that lagged behind the IaaS stuff. The other thing that I like to point out is for things that are not covered with resources, there is a catch-all or a fallback. It's not ideal, but it is a way to get done what you need to get done if we don't have coverage yet. And that's a ARM template. So you can actually, there is a resource for provisioning using an ARM template. And it's not ideal because it doesn't have state for the template. It is, that state is in Azure. So it basically transitions the state to Azure. So essentially what happens when you use that fallback is Terraform is going to think it needs to make a change all the time because it just doesn't know what that ARM template is. So not ideal, but it will get you through if you're in a tight spot. And hopefully, not hopefully, you will have to use that less and less as we get more and more coverage from a Terraform perspective. The other two things that I want to touch on here before I do the next demo are expressions and dependencies. I've touched on dependencies a little bit. So between resources in a configuration, you can have dependencies, and those dependencies determine the order of operations. So what can be done before something else or what needs to wait on other things. There are two types of dependencies. There's an implicit and explicit. I will show you implicit in the demo. The explicit is actually using a depends on. So if you have two resources that depend on each other, but you don't have an implicit dependency, you can use the explicit by just putting a property in there that says depends on and then point to the other resource there. And that will cause that order of operation to be updated there. The other thing is expressions. So you don't always, well, having a configuration that had hard-coded strings all over the place would be less than optimal. So expressions are used to get output from one resource and use it as input to another resource. So I'll show you how that works as well. And those are very common in Terraform. All right, so I'm going to jump to my next demo here. So I will do a check out demo 2 and go back to my configuration here. So I haven't changed the backend at all. I'm still going to be using the same backend. What I've done in the configuration here is I have the same resource group, and then I am adding a virtual network, and then adding a role assignment to that resource group up here, giving an existing user identity read permission to that resource group. So what you'll see here are a few different things. First of all, the different resources. I'm sure we understand what those are at this point, but the example of an expression here, this is using Terraform 0.12 syntax. So essentially what this is doing is pointing to the resource group resource. So it says this type of resource, the resource group resource, with this name, I want to get the location of that thing and assign it to the location of my VNet. So I'm putting my VNet in the same location as my resource group. And the same with the resource group name. I'm getting the name property of the resource group and assigning it to the property of this VNet. So that does two things. It makes it so I don't have to type that same stuff all over the place in my configuration, but it also, like I mentioned before, creates the dependency. So because this VNet needs the output of this resource, it's going to make sure that this resource exists before it tries to create this virtual network. The other thing that I'll point out in here is there is a data source here. So a data source is something that you don't manage in your configuration itself, but you need information from it. So in this particular case, I need the information about a user identity so that I can create a role assignment from that. So these are things a lot of times customers have a central team that manages their network infrastructure. So teams will create network and then just tell the other app teams, let's say, about the name of the VNet that they, or subnet that they can use for their application. So that team will use a data source to actually reference that subnet and be able to do things to that. So these are things that you're not going to manage. If you take this out of the configuration, it's not going to delete that like it will if you take a resource out of a configuration. If I apply this and then remove this resource from the configuration, Terraform is going to delete that next time that I run it. That's not the case for a data source because I don't manage it. All right, so with that, I will go back here and I will do a Terraform plan out. Plan.out. So what this is going to do is check to see what changes need to be made in my production environment based on what's in my configuration and output that to a file so that I can use that for an apply. And that does a few different things. It makes sure that what I did in my plan. So if I do this right now, go away for a few hours and come back, I can make sure that I am going to apply exactly what I had seen in my plan when I do my apply, but it also allows you to share that. So if I pass that plan to somebody else and they're using that same backend, they could actually apply that same change using the Terraform apply. So you can see here what it's going to create is it's going to create a role assignment and it's going to create that VNet. So if I now go apply plan.out, it is going to go ahead and create those things for me. All right, and that should just take a few seconds. And once that is done, I will move on back to the presentation here. All right, so that created those resources, and if I actually go into my resource group now and refresh this, you'll see which resource group is this? So you'll see the demo.vnet in there. And if I went into IAM access control here, you would see the permission that I gave, the role assignment that I gave there. All right. So,
Mark,
is there a question? Yep.
Yeah, there is a question in a chat before we continue with presentation. So it says,
yep.
What can we as customers do if there is an Azure resource that can no longer be provisioned using Terraform after breaking changes introduced on Azure end? After several months pass and no fix is released. So continue, besides, of course, reporting the issue on AzureRM provider GitHub and getting innocent bystanders to upvote for it.
That's the best thing to do, is to upvote. Like I said, we are going to be improving that process. So the back end does make breaking changes. My team also owns, my broader team, the Azure Management Experience, owns the SDKs and the SDK process and stuff like that as well. And that the ability for teams to make those kind of breaking changes is going to change in the near future. So it will be near impossible for them to do that. So that should become a scenario that happens less. But in the meantime, definitely create the GitHub repo and shoot a note to me as well if you have scenarios that's blocking you. And if it was an API change, not a backend change, you can actually, and you should, lock to a specific version of Terraform that has the functional code in it, and then just work with that until the backend is fixed, or the API is fixed, or the Swagger is fixed. All right. I have just 2 more slides here, but this is kind of diving into the deep end of the pool. But I think it's important to at least show you these things, because they are things that you will see anytime you try to do stuff in the real world. So I'll talk about variables here. So variables are used in Terraform. They are defined in so you have the resource keyword in HashiCorp language. There's a variable keyword as well. You define the variable that way, and that's just defining variables that are going to be needed in the configuration. And then you can declare what the values of those variables are in a number of different ways. If you don't define them, or you don't provide them at all, you'll be prompted for it when you run Terraform plan and apply. But typically the way the customers do it, and kind of a best practice is to have a terraform.tfvars file to have to provide variable values that are not secrets. And I'll show you what the syntax of that looks like. And the last way is you can actually pass them on the command line. So when you run Terraform plan or apply, you can pass the variable name and variable values on the command line. Again, that's not used very often other than playing around. And then you can use those variables in your configuration by saying var dot and then the variable name. And the next thing is secrets. So for the vast majority of configurations that are out there, you're going to have secrets. There are a number of different types of secrets, obviously. Anything that's considered a secret, you can store in a secret manager. AWS has them, Azure has them, Vault or HashiCorp has it itself. But you can store those things in there and then reference them using a data source in the configuration itself. And I can show you that, or I will show you that in the configuration. The next thing that we'll talk about, touch on real quickly, and I'll show you in the example, is iterators. So in Terraform 0.12, you have the ability to have a concise configuration where you can have a number of, well, as an example, you can have a number of subnets with a single block in Terraform, and then tell it how many you want to create. And then there are dynamic blocks, and the dynamic blocks are if you have a block within a resource, and I can show you an example of that. You're going to have multiple of those created as well. And then there are built-in functions that are super helpful for doing things like string manipulation and getting stuff from the file system and networking, so setting up subnets and things like that. And the last one is, I'm not going to show you this in the example or in the configuration, but you have the ability to do conditional things. So one of the places that that's used often is with the count. So if you use count equals and then set it to a condition, you can set it to a number based on some condition. So it can be very flexible and powerful. All right, so let me jump to my last demo here real quickly.
So your session is the last one, so you can go a couple of minutes overtime, no problem.
Okay, thank you. I was going to have to talk really fast here. All right. So what I will show you here real quick, I will show you what I'm going to do with this configuration and then run it because it's going to take a couple of minutes, and then kind of highlight what we're doing here. But essentially what I've done with this configuration that is different is I have my VNet. I'm adding subnets to that VNet, and then I'm adding security group assignments to one of the subnets in there. And I'm also creating a VM to that. So it's a few different things there. Yeah, so I will be adding 3 subnets, 3 security group roles, and then creating that VM. So I'll go over here and do TF plan out, and then go back and kind of show you what I'm doing in the configuration to get this output. And then we'll summarize here super quickly. And I'm happy to share these configurations if people want to kind of take a look at these. But you'll see when I do the plan here that we will have those new subnet security groups and the VM. And I will point out a couple things before we go back to the configuration. All right. It's coming. All right, here we go. So as you can see here, I have a Linux VM that's being created. You can see that I have an admin password that I'm passing in, and it's saying that it's sensitive value here. That is because it is a secret, and it's not something that wants to be displayed in the log output. You can see that it has a NIC that's going to be assigned to that VM, and then it has security groups, and you can see that there are 3 different security groups that are being created here, and then I have 3 different subnets that are being put into that VNet, and then I just have an association with those. So that looks good. So I will go ahead and do a TF apply plan.out. And while that's running, I will jump back to the configuration here and show you some of the interesting stuff that I did there to that. So first thing that I will point out, so the first couple things that I'll point out to here, to get those 3 subnets created, I just have this single block that is my subnet block, and it's got my name. And what I did, the magic here is this count property, and the account just says create this many of these, and I'm passing that in as a variable. So if I come over to my vars.tf file, you can see that I've defined a few different variables in this file. There's a number of subnets, there are security rules, and then there's the secret ID and key vault name itself. So in here, in the variables, I have a default for this variable, and I don't define a default for the other ones. That just allows me to have this default. So if I use this variable and don't pass in a value, it's going to use that default. And this variable, you can see that in 0.12, it supports a complex object. So it is actually an array or a list of complex objects that can be passed in, and I can show you that in the variable itself. The other two are just strings. So the declaration of the variables in here, I just define the variable name and then the values of that variable. In this case, it's the complex object that I mentioned. It's an array of the values that will be used in my security group. And then I just give the name of the secret ID in the vault in here. So back in the main file, you can see that the other thing that I want to point out here is this function that I use to define the subnet for each of these subnets. So instead of trying to calculate what the value of each of those subnets should be, I can very easily come in here and use this function to say, take the address space of my VNet and then split it out. So add 8 bytes to it, and then use a count to actually generate the address prefix for each of the different subnets. So that is a very concise way of defining the 3 subnets. The next thing that I want to point out here is the dynamic keyword. Again, 0.12, new to 0.12. What this allows you to do is have, so this is a security rule block typically. So instead of having 3 or 4 different security group blocks in here, I can have a single dynamic block and then say for each of the rules that are defined in my variable, take the information and assign it to the values in here. And I do that using this security rule value.name and all of that kind of stuff. So this gets that information from the variable and assigns it to these. And then there'll be as many of these as I define in my variables here. So if I add another block here, I'll end up with 4 security rules in here. So it makes that super easy and powerful. And you can see here that I have 2 other functions that I'm using here to make sure that the name of the security group rule is in lowercase. And for this protocol, I'm making sure that it's title cased. So the other thing that I will point out here real quickly before I jump back is in the VM. So in the VM, so the way that I'm getting the secret into the VM is I have defined a key vault. So I have a data source for the key vault. So that's already out there. I don't want to manage it. I just want to reference it. So I get the key vault, and then I get the secret from the key vault. And then I reference that in my password property by saying data key vault secret, give it the name of the secret, and then just get the value of that. So that assigns or gets the secret from the key vault and assigns it to the password there. Then I can just build up the VM from there, and I don't have to pass passwords in to the configuration itself. But like I said, that does get saved in state, which is why you want that centrally stored and all that kind of stuff. All right, so if I jump back here, you can see that that was applied after a little under 2 minutes. So I have my whole environment deployed and ready for me to use. And if I refresh the screen here, you'll see that I now have my virtual network and I have all of that stuff defined and deployed. All right, so jumping back to this, I would just have a couple more slides and then we'll close out. So I'm not going to show this, but modules are something that can be used to set up best practices for your organization. So you can group configurations, if you will, into modules and include corporate best practices or defaults or whatnot into the configurations so that other users can actually use them. There is a public registry that has some modules out there for Azure. This is not something that we have focused on as a team, but it is something that we maintain some modules for, and it's something that the community contributes to. But most of the time, these are just used as kind of starting points for customers. Customers build their own modules to do, like I said, their own best practices and all that kind of stuff. So to kind of close up here real quickly, I just want to talk about what's next from a Terraform perspective. I showed you Terraform itself, but what's next for Azure and Terraform is the conclusion of the Azure RM investments that I was mentioning before. Our goal is to get to 100% coverage of Azure services, and that's both breadth and depth. So we want to make sure that whatever customers want to do in Azure, they can do with Terraform. And we will get to a point where we have an SLA where we can say when a service goes to public preview or to GA, Terraform will be supported in that service. And when new features and functionality come out, they will be supported when it goes to a public preview or GA. We will talk about the details of that when we get there, but that is something that we are working towards and can see kind of in the long run. And so, so from that, definitely let us know how we're doing. Get in touch with me, create issues, let us know where we need to focus, where we're missing. We want to have feedback. We can use all of these words and tell you what we're going to do, but it doesn't mean anything unless you guys actually see the benefits from that. So definitely let us know what your needs are and if we're getting things done. So other than that, when we share out the deck, you can get reference to the Terraform documentation as well as some of the learning on HashiCorp and stuff like that. So with that, if anyone has any questions, feel free to yell. And I appreciate your time.